Okay, I'm going to go over tangents assignment problem 3. All right, so we'll start with the picture. Here's the graph of y of t. This is the graph of y of t equals 100t minus 16t squared. So the black line is the graph of this function. Okay. Now in this problem, the idea of this problem is we want to find the slope m of this green line here. This is the tangent line. The green line here is the tangent line. Our goal is to find the slope of the tangent line. This is the instantaneous rate of change, otherwise known as the instantaneous velocity. The slope of this line is the instantaneous velocity. Okay. All right. So when h is 3.25, the interval, right? Remember it's 3 plus h. When h is 3.25, the interval is 6.25. That's and what you're computing, what you would compute in that case when h is 3.25 is the slope of this secant line, this red secant line here. When h is 2, 3 plus h is 5, and you're computing the slope of this secant line here. When h is 1, the interval is 3 plus 1, otherwise known as 4, and you're computing the slope of this secant line here. Right, you can see from 3 to 4 there. Yeah. Okay. When h is 0.5, the interval is 3.5, and you're computing the slope of this secant line here. Now the thing to notice is as h approaches 0, right? H approaches 0, right? We're approaching 0, we're getting closer to 0. As h gets closer to 0, what happens to these secant lines, right? These secant lines get closer to becoming the tangent line. And so the slopes of these secant lines as h approaches 0, as we pull back towards 3, the slopes of these secant lines get closer to the slope of the tangent line. And so that's what's going on, okay? And one of the sticking points for students is this idea of shrinking the interval down to a single point. Here you can see that the interval is shrinking. It's shrinking down to a single point. Now, look what happens, right? When h is 0, when h is actually 0, our interval is 3, 3. 3 plus 0 is 3. The only point in the interval 3, 3 is the point over 3 of 0. That's shrinking it down to a singular point. All right, so that's really what we're doing in all of the problems here, is that we're looking at 3 plus h in general, and then we're saying what happens as h goes to 0. When h goes to 0, the secant lines get closer and closer to becoming the green tangent line here. All right, so that's the big picture idea. Now let's do the computations. Again, this is problem 3 on the tangents assignment. So y of t again is 100t minus 16t squared. The interval is 3 plus h. Oops. Okay. So change in y over change in t. First things first, let's just write down the formula. This is y of 3 plus h minus y of 3 all over 3 plus h minus 3. So the first thing you'll notice is the 3's cancel there. That leaves an h on the bottom. All right, so y of 3 plus h, that's plugging a 3 plus h in here for each of these t's. So you have 100, 3 plus h, minus 16, 3 plus h squared. Okay, that's exactly this piece right here, minus y of 3, so that's 100 times 3 minus 16 times 3 squared. Okay, and we'll put this back up here. All right. Whew. Okay, so 100 times 3, 300, 100 times h, 100h, minus 16, 3 plus h squared. Let's see, that's going to be a 9 plus, let's see, let's look at this, okay? 3 plus h, 3 plus h, I think foiling here. Let's see, that's a 9 first. Outer, 3h plus 3h is a 6h plus h squared minus, okay, so minus a 300, a minus times a minus, plus 16 times 9. 9 times 16. 4, 9, 10, 11, 12, 13, 14, 144. All of this is over h. All right, so you'll notice that we can get rid of these 300s. Okay, how nice. 100h minus 9 times 16. Oh, look at that. Minus 9 times 16. We just did that, right? 9 times 16. So minus, yeah, minus 144 minus 16 times 6. Let's see, what would that be? All right, let's do 16 and 6 here. All right, that's 36, 6, 79, 96. Minus 96h, oops, minus 16h squared, plus 144. All of this again is over h. Oh look, oh look at that, 144 goes away. I honestly didn't know that was going to happen, but it's nice. So then we have a 100h minus 96h minus 16h squared all over h. At this point you might realize that you can cancel this h here, here, and here. We could also combine like terms here. Let's do that. Let's do that. Okay. Sounds good. Good suggestion. Why, thank you, sir. 100 minus 96, let's see, that would be a 4, right? So we have 4h minus 16h squared all over h. Now again, we have to cancel with each of them, so h cancels there and cancels there. To see that, we could factor out an h. Let's factor out an h here. We've got 4 minus 16h all over h. Cancel, cancel. and we're left with 4 minus 16h, which is the correct, you have the correct answer. All right, so first little box there, change in y over change in t, 4 minus 16h. Okay, now we want to shrink it, shrink it down to, so what h do we need to use to shrink it down to a single point? Remember that we found this calculation, the change in y over the change in t, the average rate of change over the interval 3 plus h. So to shrink this down to a single point, h needs to be 0, because when h is 0, that gives us 3 plus 0, otherwise known as 3. The only point in this interval is the point over 3 of 0. That still bothers you? Let's look at it graphically, thinking of the t-axis. Let's see. So 3 is included on the left, and we're going from 3 all the way to 3, right? Which is just that. Okay. Right. So the second box on there, h equals 0. And now lastly, dy dt. So when we have the little triangle, that's the change in y over the change in t. That's the average rate of change. When we use the little d there, we mean instantaneous. All right. So the instantaneous at t equals 3. Now, a common mistake would be to put the 3 in there. But see, that's an h, right? That's an h. So how do we evaluate just at 3, right? Remember the graph, right? We had lots of secant lines, right? And as h went to 0, we had the instantaneous, right? Just the tangent line there, right? So it's exactly the same idea as why h equals 0 shrinks the interval down to a point. Okay. So we have 4 minus 16 times 0, which is 4, and the units, feet per second. Good luck.